Our first area volume question is from the 2019 exam. It was question number 5. In this question, we are given region R. It is defined by g of x, which is a cosine function, and h of x, which is a quadratic function. Without a calculator, you've got to decide which graph is which in our diagram over here. Some things that you can look at is that I know h is a quadratic, so I'm looking for a parabola. Because I have a negative in front of that too, it's going to be upside down, and I can see h of x is fitting that description. Another thing that we can do is look at the y-intercept. So if I plug in x equals 0 into h, if I find h of 0 and calculate that out, I'm going to get 4, and I can see that h hits the y-axis at 4, so that targets this upper curve is my h of x, and the lower curve is my g of x. If I want to find the area of R, which is part A, I'm just going to do upper minus lower. So I just do the integral from my low x is 0, my high x is a 2, and I just do upper minus lower. So this first statement is going to earn you that first point. You don't have to write h and g. You could write the actual functions, the expressions in there if you want to. Just make sure that you put the parentheses around that second one so that you get that distribution of that negative. And that answer would be okay as well to earn that first point. And then from there, I'm going to have to do this antiderivative. Before I do that, I'm going to simplify a bit. So I'm going to take my 6 and subtract the negative 2, and that's where this 8 comes from. And then for the rest of this, I just went ahead and distributed the negative to that cosine term as well. So now I have to do an antiderivative of this. And it just goes term by term. The antiderivative of 8 is 8x. The antiderivative of this middle term is done over here. And I came off to the side so that I could do a u substitution. So this is my u substitution work over here on the right, which finds that antiderivative of 2/3 and the quantity x minus 3 cubed. So that comes to this part right here. And for my other part, my last term, again, I need to do u substitution and let u equal that pi over 2x. And I've done that work over here off to the side. And I've come up with this is my antiderivative. Nobody's looking for this u substitution work off to the side. So however you can just come up with those antiderivatives is up to you. If you're better at doing them in your head, or if you go off to the side, I would suggest pulling out of the problem and doing your work and then pulling your antiderivative back in. That antiderivative is worth 2 points. And then I just need to plug in my upper, which is the 2. So I plug the 2 in for all of my x's. 1, 2, 3. And then I plug in my 0 for all of those x's. I come up with this. Notice that this expression has a sine of pi and a sine of 0. If you know what those are, then you can continue on and simplify in this problem. Sine of pi and sine of 0 are both 0. If you're unclear what sine of pi is or what sine of 0 is, then you can just leave it as this step right here. So this would be fine as your final answer. If you don't know how to simplify it, then just don't, because if you simplify it and you do it wrong, then you lose this answer point. But if you just don't simplify, then you're good with this answer right here. In part B, I'm told that this region R is the base of a solid and that cross-sections perpendicular to the x-axis, and that's a key phrase right there. Perpendicular to the x-axis tells me that my integration is with respect to x. And in order to find volume, we just integrate the cross-sectional area. We are told that that area is 1 over x plus 3, so we don't need an area formula because we are told what the area of a cross-section is, so that is what my integrand is, the 1 over x plus 3. To do this integration by hand, I would do a u substitution, and that's done here off to the side. I do my replacement. I change my limits by taking my original limits of 0 and 2 and plugging them into my u equals equation. Gives me the 3 and the 5. Antiderivative of 1 over u is the natural log of the absolute value of u. And then I just plug my limits in my volume is natural log of 5 minus natural log of 3. You can stop it right there, but if you remember that subtraction property of logarithms, that you actually just divide those arguments, you can take it one step further, but you don't have to do that last step. Point-wise, if you can set your integral up correctly, you earn a point, and if you can come up with that final answer, you earn another point. In Part C, I'm asked to write but not evaluate an integral expression for a rotational solid. I'm rotating around a horizontal line. What that tells me is that this is going to be an integration with respect to x. It's important to look at where that y equals 6 is in relation to my region R. What I see is that I have a gap between that axis of rotation and my region R, which tells me I'm going to use a washer method. So I just laid out the template here for a washer method. My limits are a low x to a high x because this is an integration with respect to x, so that's 0 to 2. I have to figure out which of these is inner and which is outer. For my axis of rotation, whoever you hit first is your inner function, and that's h of x. And then the graph that you hit second, the one that's further away, is g of x, and that's my outer. So my outer radius is g of x, and I have to subtract to offset that axis of rotation squared. So this is my big R squared minus, and then my inner radius is h of x. And again, I have to offset for that axis of rotation of b and y equals 6. So my inner radius is h of x minus 6 squared dx. I was told I don't have to evaluate this, so I just leave it just like that. Point-wise, if you have the pi in the correct limits, you earn this point. And if your integrand is correct, you earn 2 points for that. If you forgot maybe to subtract the 6, then you would maybe earn 1 point. If you had them reversed, you might earn 1 point. Also, if you have within each of these binomials, if you have the two terms interchanged, so if you wrote 6 minus g of x, or you wrote 6 minus h of x, that would be full credit as well.